Question 15. In each question below, 3 images labeled A, B, and C are the images of the object under a particular transformation. So the transformation could be a translation, axial symmetry, or a rotation. For each image, state which transformation is used, and in the case of a rotation, state the angle and direction. So here's my object, Tetris, and here's my A. Well, it hasn't moved, so it's either rotated 360, so 360 rotation. We're not given a plane here, so we don't know whether it's moved like to the right or to the left or all the way around, so it could also be a translation. Could be either. This one. B, well, what has happened to B? B looks like it has gone through an axis and out the same distance to the other side to reverse it around. So definitely axial symmetry for B. And C has rotated, and it looks like we were facing west, we're now facing south, so we've rotated this way in an anti-clockwise direction, which is positive, so a positive, and we've gone from west to south, so positive 90-degree rotation. Now B, so the object, just we're dealing with colors here, so let's just focus on the purple part. So purple has, we just have rotated, we're kind of gone from here to here, haven't we? Yeah, we've gone from here to here. So we are going, so I'm starting with the wrong one. No, I've gone this, I've gone purple to here. Purple's gone one block up that way, so that's a negative. It's gone negative 90 degrees rotation. For B, we could use the rotation again for B, because we could say that purple has moved, it was in this position, so it's gone around once, twice, so it looks to me to be a positive rotation of 180, and it could also be a negative rotation. It would get it into the same place, so B is a positive or negative rotation of 180 degrees. And then C, what has happened with C? The color's still in the same place. Purple, well, purple has just moved one block over, so that's one rotation around this way, so this is positive one. When I say one rotation, you know I mean 1/4 of a rotation based on our north, south, east, west of 1/4 of 360. Question 16, the diagram shows the triangle ABC. Draw the image of the triangle under the following transformations. Okay, we'll start with axial symmetry in the x-axis. So through the axis, out the same distance the other side. Through the axis, out the same distance the other side. Down 4, down 4. So here's my new image. So that's symmetry or axial symmetry in the x-axis. And we're given space down to write down the coordinates of the vertices. So we will write down, well, we don't need to do it in order. It doesn't say A, B, C, they're not labeled, so we can just take each individual point. So I've got a 1, a -1. I've got a 5, a -1. And I've got a 2, -4. Okay, let's do the next one in blue. So we're dealing with central symmetry. So through the origin out same distance, B will end up here. C is 4 away from B, so the best way to do C is to come to here, 4 away from B, and then A, if we imagine A being up 3 and across 1 from B, we would get to here for A. So this is my symmetry in the origin for number B. So I have a -1, -1. I have a -5, -1. And I have a -2, -4. And then axial symmetry in the y-axis. If we just maybe pick our points out, we're going to go across 2, so we're going to get to here. B is going to get to here, and C has to go 5, so it's going to end up at -5. So this is my symmetry in the y-axis, and my points are -1, 1, -2, 4, and -5, 1. Question 17. The diagram below shows the triangles DEF and PQR on the coordinate plane. The triangle PQR is the image of DEF under axial symmetry in the line P. On this diagram, draw the line P. So if DEF and PQR is the image of DEF, axial symmetry. So you can see here F has moved to Q. A jump of 1, 2, 3, 4, 5, 6, it looks like. So this looks like my line P here. Let's just double check the other ones. E, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 does work for E too. So that's my line P. Then we're told the image of triangle DEF under axial symmetry in the line Q. So we have the line Q given to us on the diagram, and now we need DEF axial symmetry in Q. Well, we need to drop down perpendiculars from there to there. It's 1.5. It's going to get me to there. F, same again, need to drop down. Looks like it comes down twice. Looks like it gets to here. And my E, if I just connect these, where's my E going to be? My E is going to be across 4 and down 1. So it looks like E is going to get to here. Let me just double check that. So yeah, it's actually in line. E and F here, so it does bring me down to there. So this is the image of triangle DEF. So I have D prime here, I have F prime here, and I have E prime here, and hence write down the images of the vertices of the triangle DEF under axial symmetry in the line Q. So we have D prime 1 minus 1, E prime 5 minus 2, and F prime 3, 0. So tricky enough with the axial symmetry when it's not bang on straight, but you can see here the relationship between the symmetry on both sides of the line. You can see it's equal.